Okay, this is the P3 paper from October 2020. It's question number 8, and as we can see, this is a differentiation question. What have we got? We're going to have product rule there. We can see we're going to be differentiating exponentials and trig functions, and I think later on, we're going to be differentiating logs. So pretty big differentiation question. Let's make a start to it. It says the curve C has the equation y equals gx, where gx is equal to this product that we've got here, okay, e to the 3x sec 2x, all between minus pi over 4 and pi over 4. Can we find g dash x? Yep, we can. We just need to explain what we're doing. So if gx is equal to e to the 3x sec 2x, then I'm going to call u is e to the 3x, and I'm going to call v is sec 2x. So it's now just making sure that I can do my differentiation of these various different complicated functions. So differential of e to the x, differential of e to the x is e to the x, differential of e to the 3x is e to the 3x multiplied by the differential of what's there. So in other words, 3e to the 3x. Same idea with sec. The differential of sec is sec x tan x. So I'm going to get sec 2x tan 2x and then multiplied by the differential of what's there. And so in this case, multiplied by 2. So let's just tidy that up. Need to go back and do some basic differentiation if you're struggling with those two bits there. But then g dash x, the way that I write my products is I say is v du by dx plus u dv by dx. So working that out then is just a matter of substituting it in. V du dx is those two, and looking at them, I'm not going to write sec 2x 3e to the 3x. That's not a very good way of writing it. So actually, even though that is what I'm going to be doing, I'm going to write 3e to the 3x sec 2x. I just want to make it less likely for me to make any arithmetic errors, algebraic errors as I'm going through here. And then u dv dx is that times that, and again, I'm going to put the 2, I'm going to put the 2 and the e to the 3x first before I then say sec 2x tan 2x. Now let's just go back and say, what does it say here? It just says find g dash x. It doesn't say anything about simplifying it or tidying it up. So I'm going to leave that like that. Get used to that. That should be something that you're more than happy to do. If they want me to do any more work with that, and they do, they'll make me do it with the second part of the question. So the second part of the question says, right, can we find the x coordinate of the stationary point? Well, hopefully you can remember that stationary points occur, tell the examiner, for a stationary point, we just want differential equals 0, don't we? So for the stationary point, g dash x will equal to 0. So I'm going to get 3e to the 3x sec 2x plus 2e to the 3x sec 2x tan 2x. Should that be a 2 or a 3? Yeah, no, that's okay. Just checking my own work there. Equals 0. And when we got to that stage, then the e to the 3x and sec 2x can now come out as a factor. That and that can come out as a factor. So that means I am simplifying this thing now, but only because I have to as part of my work. So e to the 3x sec 2x comes out as a factor, which is going to leave me 3 plus 2 tan 2x equals 0. And although that looks absolutely horrendous, I'm experienced. I've done these questions before. I know that this is a technique that they use quite often, where once I get to this stage, this is equal to naught, or this is equal to naught, but that bit can't be equal to naught. Okay, if you just think about what e to the x looks like, e to the x, one of the key functions of e to the x is the fact that it has an asymptote of naught. E to the x doesn't equal naught. So because of that, you don't need to write any of that down, that's just explaining it to you. E to the 3x sec 2x equals naught, or 3 plus 2 tan 2x equals naught. Just no solutions to that bit. So that's nice and handy. Actually, I don't need either of those things being done like that. So what that now means is I'm just having to focus on that bit there, which I should be able to do relatively straightforward. So we get 2 tan 2x equals minus 3, tan 2x equals minus 3 over 2, or 1.5. And I'm not going to go ahead and just do all this. This is work that you can do yourself to get to this answer here. Just inverse tan. Be aware of the cast diagram. Doesn't say anything about decimal places or significant figures, so I'm happy just to leave it as 0.49. I've done it to 3, but you could do it to however many you want to for that part there. Okay, on to part 2 now. If you are struggling with that bit, go back and look at one of my other videos on the channel, and it'll explain to you how to do that sort of thing. Different curve has an equation, x equals log sine what? Right, this is a completely different question. So as you look at this, you almost say, right, this is part 1 and part 2 are not connected in any way. Actually, I should have called that part 1, part A, part 2. So we've got, what have we got here? We've got x equals log sine y. And what do I need to do with it? It says, can we show that dy by dx is equal to whatever? Okay, that looks a little bit complicated to me, but what I can do is make a game plan to get started. That's in my mind, I don't miss that out. So it's e to the x over some function of x, and they're going to have to find out what that is. But if I'm trying to do, if I've got x equals log sine y, I know that the best way to attack this then is just differentiate it with respect to y, because it's a function x equals a function of y here. And then when I've got that, I'll flip that over and get dy by dx in a minute. So do I know how to differentiate log x? Yes, I do. Log x is 1 over x. So log sine y is 1 over sine y, but it's 1 over x times the differential of what's in here, times the differential of that. 1 over sine y times the differential of sine, and the differential of sine is cos y. Okay, so I get dx by dy is equal to cos y over sine y. Now at this stage you could call that cot if you wanted to, and you could say dy by dx is tan, but that's no good to me. If I go back and think about what they just asked me that they want everything in terms of x's there. So what I need to do is to then, and again this comes from experience of looking at this, is to say, well, I've sort of got sine y, or I can get sine y relatively quickly now. If I come back here and I just look at this bit here, what I can say is that if x is equal to log sine y up there, what I can do is say, we know x equals log sine y. So if I e both sides there, e to the x is equal to sine y. So now when I'm looking at this function here, if I can get this all in terms of sine y, then I can get my answer here. So it's an experience question, this one. You need to almost look at this one and then see when it comes up again in the future, that as I'm actually going through and doing this, then I can say dx by dy then is cos y over sine y, so it's cos y over e to the x. Cos y, can I rearrange this? Yes, you absolutely can, and it's something that you just need to be aware of in P3. it comes from the idea that sine, again, it's up to you whether you want to write this in or just know it. Cos squared y plus sine squared y is equal to 1. So cos squared y is equal to 1 minus sine squared y. And so cos y is the square root of 1 minus sine squared y. Now, even though I've done all that, you basically need to know this, guys. Okay, I'm talking to the, obviously, people who are looking at getting a really good score in the exam. This is question 8, it's the second part of it. It is one of the harder bits there, but I would expect you to have that in your armoury as actually just knowing that. Now, I can leave that there for showing the examiner, but basically what we're saying then is dx by dy is equal to cos y is the square root of 1 minus the sine squared of y over e to the x. And then again, we can now put the fact that sine squared y, or rather sine y is e to the x. So we've got 1 minus e to the x times e to the x, well that's e to the 2x, all over e to the x here. And then I've been waiting right to this stage to say, yeah, but I want dy by dx, not dx by dy. So if we flip that over, we get e to the x over the square root of 1 minus e to the 2x there. So if we now go back and look at what they wanted, yeah, it's fallen out into that format there. Make sure that this bit doesn't catch you out here either, about saying that e to the x all squared, e to the x squared, which is e to the x times e to the x, you add the powers, is e to the 2x. That's something that we need to know. Again, lots of different bits there where I keep saying, yeah, you need to know that, you need to be aware of that. We're talking about a high level here. How many marks is this? This is worth 4 marks here. Those 4 marks, the examining board has sort of stipulated that's where we're going to find out difference between our A star and our A candidates, or somebody who's trying to get 100% on this paper. They're going to be solving this bit, and they're going to be solving this bit. You're going to be solving this bit every single time if you're one of those candidates. So yeah, good question, a challenge, but get your marks on other parts of the paper. As a timing issue, when you see that, if you think, oh, that's a bit beyond me, okay, well, don't waste any time on that. Go back and find other marks in the paper and make sure that you're securing other marks rather than spending too long on something that might be a bit too challenging for you. But for most of you, hopefully that makes sense.